Hello, everyone. My name is Daniel. I'm a software engineer at Intel, and we are going to talk about Userspace in Zephyr. This is the topic of the day. I'll give a very brief and simplified overview of Userspace in Zephyr, and then I'll talk about how you're going to share data using user threads, and we'll go into some brief details on Syscalls, on basically how you use kernel services from Userspace, and then we'll go to talk about why and why not to use Userspace, and we'll end with some Q&A sessions. Well, for Userspace, the idea is kind of simple in a sense. You have kernel mode and user mode, where in kernel mode you have elevated privileges. Basically, you have access to everything, like all the hardware devices and all that. And Userspace have the user mode. In user mode, you have limited access. Basically, have a very limited capability to make sure they cannot do bad things in a sense. So kernel mode sometimes also refer to supervisor or privilege mode, and user mode is kind of unprivileged mode, but usually the hardware vendors usually just call them user mode at that point. User threads runs in user mode, kernel threads run in kernel mode, and most of the subsystems runs in kernel mode. Device driver, when you're coding the device driver API, they need to be in kernel mode most of the time because you need to access the hardware, like hardware register and stuff. And of course, the core kernel has to run in kernel mode, like the scheduler or that kind of thing. So, and when I say this kind of the concept is simple, is because really it's this. What you are limiting in user mode is basically limiting the user threads from accessing certain memory. Well, not exactly like memory in terms of like SRAM or like a memory map flash. It's just limiting the access to memory addresses, which means like MMIO, hardware register space. You can have a memory mapped flash area, that kind of thing. So for that, like I said, in kernel mode, kernel threads have access to all of this. That's the user space model in Zephyr. For user thread, it's like you basically grant user threads access to certain memories, certain memory regions. For example, the left 2 can access the memory region of the left 2, and the right 2 and can access the right 2. And when the left two user threads try to access the right 2 memory region, the hardware blocks the access to it. So at least for the current model, if you try to access it, it will create a page fault mostly, and then the user thread will be terminated. And because of the user that doesn't have access to everything, and by default, it has no access to most of the memory. It has basically only have access to like the text region, because you have to execute code, and the read-only data region, and also its own thread stack. So how do you share data between user threads? So, for example, we have something like this. You have, say, 3 groups of threads and 4 groups of data. They are logically partitioned. For example, you have a bunch of data that's like coming from a sensor, from one sensor, and another set of data coming from another sensor. And then you have a group of threads processing the data from both set of data. The process of sharing is mostly at build time. You can do it at runtime too, but well, the first step is that you assign data to memory partitions. So you basically group Like for example, the memory partition A has that 4 pieces of data, memory partition B, C, and D, and so forth. And then you create memory partition with reference to those memory domains. You create memory domains with reference to those memory partitions. But at this point, the memory domains are not complete. And you actually have to assign threads to the memory domain for them to be complete, because memory domain with no threads, it's like there's no purpose, because the threads are running within like the concept of memory domain, so that everything in that domain can be shared. And this is kind of the relationship between memory domain and memory partitions. Basically, so here you can see that for memory partition A, the threads from memory domain 1 and 2 can read and write the data in memory partition A, and then for memory partition B, only memory domain 2 can access those, and so forth for C and D. You can see the arrows, like, because here it's like when we create the domain, the memory domain, we assign the memory partition to those domains. So in a sense, here, so we have this. And it's kind of like a very simplified way of describing memory domain and partition. The actual setting them up requires a lot of like linker magic in a sense. So please refer to the online documentation for the examples on how to actually do this in the code. And one thing to remember, global variables cannot be accessed by any of the user threads. They have to be in a memory domain. So if you just declare in the C file, no user threads can access it. This is how you share data between user threads. The next topic is Syscalls. The main purpose of Syscall is for user thread to access kernel services. For example, you want to log a mutex, unlock mutex, give a semaphore, send something to the mailbox, that kind of things, and also like when you want to access devices, like you want to do I2C transaction or send something to the UART. And in the Zephyr model, we call them kernel objects. Here are some common kernel objects that's in Zephyr, like, for example, mailbox, memory slab, mutexes, the kind of things. But for device driver, remember that each kernel object is not the device driver themselves, but each device driver instance. So, for example, if you have, say, 3 I2C controllers on the hardware and they are enabled, you have 3 instances of the I2C controller, and you have 3 I2C kernel objects. And similar to memory access, like similar to what the memory access model, user threads has very limited. You can restrict access from user thread to each object. Actually, in a sense, in actual usage, you actually grant access to each kernel object to each user thread. So the model is for kernel thread, they have access to all kernel objects. But for user threads, you have to explicitly grant access of a kernel object to that thread. So so for example, you have 2 mutex, you define 2 mutex, and then you assign them to 2 threads, like individually to 2 threads, and each thread cannot access the other mutexes. So that's basically the model for the kernel objects, and the Syscall is in a sense, in practice, runtime is not cheap. For example, it's like this highlighted. This is basically the flow chart of the Syscall, how Syscall is being done. If you're already in kernel mode, like you're in kernel thread, it's easy. You just go straight to the implementation. Just one indirect call to the implementation. In addition to this probably in addition to running it in the kernel thread, this path is also taken when you are in interrupt. So while you are in ISR, this is also the path that's being taken when you do a syscall. For example, don't do mutexes, don't log or unlock mutexes in ISR because you may deadlock the system. And then for the user mode, this is the this is actually a kind of a simplified flowchart. I leave out a lot of the core function, but the basic idea is that you have to go into kernel mode to basically execute the implementation. So the first step, like if you're in user mode, the first step is to package the function argument. And then it goes through the previous escalation to go from user mode to kernel mode. So you can use a different set of permission, like a different set of page table for MMU and different set of memory region permission for MPU, for example. And then after previous escalation, you're in kernel mode, and then you have to unpackage all the agreement, all the function arguments into basically just the elements. So for if you pass 64-bit data with on a 32-bit system, you have to the background has to unravel this. It's like pack it in a certain way and then unpack the data. So after unpacking the data, it has to go through verification to make sure that the data being passed are valid. For example, if you try to pass a mutex, this verification has to verify that this is a mutex. You cannot just pass in any arbitrary memory address and call it a mutex. No, that's not a good thing because you would be modifying arbitrary memory in kernel mode, which basically has to have access to everything. So this verification must be done. And another part of this, like if you are passing something, you're passing a memory buffer or a string, for example, in this stage, you need to copy. You need to copy that, basically allocate a memory in kernel mode and copy the memory buffer of the string into the newly allocated buffer. This is mostly to prevent something modifying the buffer between the syscall and the actual implementation is being done. It's kind of a security measure too, because with a preemptive threat, the threat going through this can be preempted, and then something can come in and modify the buffer, and then the original thread comes back in, run with the modified data. You don't want to do that because the data can be modified in a malicious way. For example, like Bluetooth, you can massage the package in a sense to do something bad. And I don't have the return path for this, but the return path is very similar to the path here. It's just in reverse. So you package the return value, go through the previous de-escalation process to go back to user mode, and then unpackage the argument in a way so that the site of calling this function acts like it's just another function call. So this call is kind of hidden like behind the scene things for the caller. After seeing this flowchart, someone might ask why do we need user space? There's always the big question is why do I care? One very first things on why or why not using user space, or basically why not using user space, that the hardware must support MMU or MPU, memory management unit, or memory protection unit, or in the RISC-V world, it's called physical memory protection, if I remember correctly. If you have no MMU or MPU, you cannot use user space because you don't have hardware to guard the access to the memory. And another thing, like with the Syscalls flowchart, you can see like the latency goes way up for user thread. Like not just only Syscalls, but for context switching too. Even if you're switching between user threads, you have to change the page table, or you need to reprogram your MPU for the permission of the incoming thread. And another downside of using user space is that the memory usage requirements goes up, because if you're using MMU, you need to store the page table somewhere, so you can swap in and out doing context switching. And then for user thread, there's an additional stack that is needed for user thread, because when you're going into kernel mode, the execution is no longer using the user thread stack. It uses the previous stack to, in a sense, to avoid leaking data through the stack. And at least the current implementation of all the MMU code is that the previous stack is set up in a way so the users cannot access them. They, kind of like kernel thread. It's kind of like kernel thread. Only things in kernel mode can access the previous stack. And also, one thing to consider is the page alignment for memory partition, because the access granularity is for MMU is on the page size. It's like mostly is 4K, but for MPU, it might be. It's based on the MPU. For example, if you have a power of 2 requirement, so you always have to pad the memory partition region to the power of 2. So if you have, say for example, 4-byte data and the alignment need to be 8K, then you're almost wasting 8K of memory for that. And in addition to this, when considering whether to use user space, you have to understand the thread model that the user space implementation is based on. Very first thing is that there's no interactive user. I don't know why you want to have interactive user on an embedded system, but that's the model. No interactive user, no login. And another thing is that the threat model is that we are not guarding against malicious code. Although the threat model says that we don't trust the code running in user mode, however, because you have to package the whole firmware together, so if you don't trust the code, why are you packaging it in the flash? So that's the original model. That's the original model. However, with the linkable module now, things get a lot complicated, because you can basically load whatever code in there. So that's the next talk. Kind of plugging in here, but that's the next talk. And another thing about how the threat model is that it's, like I said, not guarding against malicious code. Most of the time, it's just kind of just preventing coding error. For example, instead, well, I think kind of like some of the common error in terms of memory access that you do some pointer math, you add a pointer and a size, and if it wraps around, then this is something that you want to catch and fix it in your code. So instead of it trying to access invalid memory. And the other thing is that it just isolate between memory domains. So that basically, so the bad behavior, in a sense, of the threads in one domain will not affect the behavior of the threads in another domain, as long as they don't share the same memory partition. Because if they modify the same data, and then one group is writing bad data, and then the other group reading bad data, then there's not much you can do there. So I think that's a very brief and simple overview. I hope you're all confused.
So not a technical question, but rather since in our own applications we don't use Userspace, I'm just curious if you could name a couple of real-world practical applications where this is being used.
Real-world, something I cannot talk about it here. But I don't know any commercial product that's using it, but that's mostly because of my ignorance. And one thing I just want to mention is that what we are providing is just a framework. So whether you want to use it is up to you based on your requirements, like what your product is doing. So I actually for example to this, like if you have a sensor package that you put it into a remote location that you just go there and grab the data once a month or once a year, and they don't do any like data transmission or receiving anything, you may not need user space because you don't, because you're not getting, you probably will not get malicious data that compromise the operation of the whole thing. So, but this is yeah.
Just to answer this question, I think what Daniel mentioned with regard to loadable extensions, which is something new in Zephyr right now, but it is definitely something that has been done outside of Zephyr. In the context of Zephyr right now, we have something, but it's mostly, I mean, when you want to use an MPU or an MMU, it's about guarding like a basic firmware from third-party data that you might actually have in the system, through, extensions, codecs, whatever. You want to allow firmware extensibility, and that's like one guard. But also the practical solution, and that actually basically was going to be my question, is all of the things that were listed on the slide. It's actually, there is a lot of things that we in Zephyr that we have right now where, because of historical reasons and whatnot, I mean, we don't have much of error checking, for example, yeah, or parameter verification, etc. I mean, that has changed over the years, but things that we couldn't put in the implementation that is used in the non-user space case are available in the verify function. If you go to the Syscall diagram, you see there's verify. Yeah, depending on the function, there is a lot of error checking happening there. Yeah, and if you are running a safety critical application or that's actually something you want. Right now, however, and this is my question actually, yeah. Right now, however, this is all depending on user space, yeah. We really need to figure out a way how to start moving a lot of verification and checks that we have in this function that is enabled right now in user space into the main implementation. we did that in the past with the check-if macro and stuff like that to avoid explosion in the footprint usage. But we need to figure out a way, yeah, maybe we should have like a two-level thing where the implementation and you can actually enable the verification function if needed to add more checks, yeah? So this is a question, and I briefly talked with Daniel about that. This is not so easy because with the design. My second question is, what are the differences in the implementation when you have an MPU versus MMU? Yeah.
The difference between MMU and MPU? The, well, at least most of the things are common between MPU and MMU. So thread isolation, memory domain, we all have that. I can't think of any major thing except that with MPU you're limited with you're limited by the number of regions in the hardware, so you have to be very careful on how you structure your memory to minimize the number of regions. But otherwise, there's always not always. That's one issue about whether threads in the memory stack should be able to access the thread stack of the other thread in the same domain. If I remember correctly, the introduction of that actually got introduced into when we introduced memory domain, so that every thread in memory domain can access the stack of other thread stack in the same domain. But the thing is, the ARM MPU implementation is I think it got implemented before all the memory domain things, so it has thread stack isolation built in there. So there's some difference between the actual implementation, but otherwise, at least in facing the user-facing part, the developer-facing part, if you're writing an application, they should mostly act the same.
I was going to interject again, just riffing off on us. Going back to the Syscall chart, which was all like great, and it shows all the things that need to happen. I think the marketing side of this, though, that I think got missed is that this is all invisible to app code. I mean, one of the things I think we have done best on this, and this is all Andrew, our dearly departed Andrew Boy's work. I mean, he didn't die; he's at Apple. You know, for the most part, if you've got an app and you need to get, you know, some kind of transaction into kernel code to pass an argument or whatever, you need to add a new syscall. You just declare it as a syscall, you write your validation function, and you're mostly done. And then if you've got data that you need to pass that's not arbitrary, then you might have other stuff to do. There's a function you need to call to copy the data out. If you need to add another kernel object, that's actually kind of a mess because you need to go and edit a Python script right now. But really, I mean, all of the functions, the entirety of the Zephyr API for the most part is exactly the same in Userspace. Now, again, performance-wise, that can be very different. But really, I mean, I think we've got a much stronger story here than I think really any other, you know, embedded OS, and frankly, even than like Linux does. You need to get into kernel space in Linux. It's hard, and you've got lots of tools, right? You can choose, like, you know, a sysfs node. You can open something in proc. You can do all kinds of things. But you're looking at, okay, here's your 6 function calls that you've got to implement and all the callbacks and all of that stuff. And in Zephyr, it's you just go and you add one preprocessor token and you're done. So
actually, extending to that is like even if you declare a function in syscall, like in this is like it's all behind the scene. So even if you set config user space to no, at least from the API user perspective, they don't need to change anything. They can still call kmutex log. It will function the same. in their perspective.
Thank you for this presentation. I just have a question. So if you access something in another memory domain and you don't have the permission, you mentioned that the thread will be terminated. This is the case on both MMU and MPU.
Yes, because it will, well, at least on the MMU term, it will cause a page fault, which goes through I think it goes through C fatal error, and then you will eventually call K-thread abort. On the on the MPU side, the hardware may call it a different, like permission, like privilege access denied, that kind of thing. But the mechanism is still the same. The idea is still the same. It goes through C fatal error, and eventually you will call K-thread abort. And
the scheduler will just select another thread. It could be in another domain.
Yeah. When it returns from the fault, it will. You will select if you are using the switch, you will try another switch. If you are not using the switch, I'm not familiar with that part of the code, but yeah. And
I suppose if it was essential, it will just terminate it will just do a fatal error. It was marked as essential thread. Okay, thank you. Just also another question: would you consider a good practice to put the whole code in a module and use library app named instead of just creating the different partitions? Just put the whole memory domain in a library instead of just creating each memory domain manually with the different partitions.
There's an API that app estimate is called, basically gives you some preprocessor stuff where you just declare this variable goes in this domain.
Okay.
Otherwise, what maybe it's wrong.
Thank you.
Do we have any tooling or anything that helps, visualize to some degree simply like just the memory partitioning layout for, for someone who's trying to set this up? And so whether it's things like the alignment restrictions and saying, hey, maybe if you, reordered these, you'd be better off and not waste as much space or anything of that nature?
No, we don't. Okay. At this point. Well, but we have something like this to memorize the placement in the linker circuit, but that part doesn't depend on user space. We have I don't remember, it was done a couple of years ago.
As a developer of a driver for a peripheral that is really custom and doesn't use a standard API, how difficult it is to expose my code in Userspace? Do I need to worry about all the marshalling of the arguments, or will this be transparent, like for the other system calls? You
don't have to worry about the marshal, like the left three and the marshalling. You don't have to worry about it. It's done behind the scene. What you need to implement is the verification function and the implementation, and declare your API as a syscall.
I have a question. So there is a set of related technologies like this trusted firmware RAM and trusted execution environment. So if I were to explain to our customers and users, when do you use a user space and when do you package your custom code in the trusted execution environment, would you have any advice, or this is just something you're not familiar with?
To be honest, I'm not very familiar with all the like the trust zone and that kind of thing. So I'll refrain from commenting.
User space is portable. If you need to run on a different architecture, it's what you choose.
Yeah, here's another question.
Yeah, just a quick question. You said in your slide that there is no users in Zephyr. Do you know if in the future there will be, or it's not planned at all?
Personally, I don't see this use case for having a user on an embedded system, but.
Well, I can tell you, if you sell a product, maybe you want some of your customers have some engineers, so they want to access the product and do some stuff. But then if your product is doing something bad and you want to send another people, like maintainers, they want to have access to other features. So the engineer will log in as an engineer and will do some stuff, basic stuff, is know-how. And then if you want to send a maintainer, he will log in as a maintainer and can access more features and can do more stuff. That's something that we may need.
I don't know, but like as a personally, I think you are stepping into the Linux territory. Like as a.
Yeah, I mean, but to his point, I mean, there are MCU platforms that are, you know, considered crossovers, and as such, they're fairly powerful. And I can envision something like that, or having a display with the user input to it, and you want to kind of partition that off in a way that is not going to, you know, someone's sitting there screwing around with it, trying to see how they can break it, right? And it's on a critical system behind it. Well, but I think one of the keys here is if you determine that you have a product requirement for it, then this is here. It's transparent to the application, and the only cost is the overhead of the marshaling, the escalation, all that path right there. And if that's acceptable for your application, then that's what you're going to do, because if it has that requirement.
I'm just thinking out loud here. Well, you will have to implement, like, for example, maybe as a server, you would port it over to Zephyr, something like that, or login terminal, that kind of thing. So the Userspace framework doesn't prevent you from having users in the system. It's just that the threat model, what is the threat model that the Userspace implemented is based on, does not. What was a good word for this? It's like it's just not the threat model. It just doesn't. It doesn't have that use case in the threat model, and we don't really cook for that at this point. So if you have something that the user space is not, it's not adequate for use case, feel free to create an issue and post it on the mailing list or this call so we can talk about it.
I think there's an issue already, just to mention. But actually, it would be wrong to say that Zephyr does not support users, right? We have one single user. We actually have shell, and we have like recently you can do all kind of crazy stuff with the shell that almost looks like, you know, you are logged in a Linux system sometimes, yeah. But my question is, I mean, this is like just this Syscall slide is actually very, as you said, it's simplified. A lot of things is happening behind the scenes. Mm-hmm. So when we build Zephyr, everything builds, etc. Obviously, we know there's a lot of complaints about the multi-stage build, but we do that not only for Userspace, we do it for so many other things as well. But I mean, is that a lot of overhead when you enable Userspace, and what actually goes behind the scenes? Is that, I mean, how complex it is to get things right to operate in this manner and using this workflow?
Well, I'm very biased in this instance, so I would say that it's not exactly easy, but it's not that hard, because the things you need to implement is the verification function to make sure that everything, the function arguments are valid before you send it to the implementation. And we have examples, a lot, not exactly a lot, but we have example in the documentation, and we actually have a lot of implementation or verification in the code itself, so they can serve as a learning material in a sense. Otherwise, as a developer, most things are intermediate difficulty, but for the build system, is there. It may take a while. Well, in terms of building, it might take longer because it's pass all the file, look for the syscall, and then generate all the behind the scene functions. So it's not free.
All right. Yeah, we're actually at time, but let's give a round of applause for Daniel. Thank you so much.
Thank you.